I guess we're live, guys. Am I audible to everyone around the country? Yes, I am. So, hello, guys. Welcome to another episode where we are going to solve Irodov problems and we're going to have fun. Yeah, I'm audible also. राशि थी मैं था तुम था कौन था ऑल राइट सब कोई नहीं है इंडियन टीम का बहुत खराब परफॉर्मेंस था आज तो आई एम फीलिंग वेरी सैड टुडे बट बिफोर वी गो एनी फर्दर आई नो देयर इज अ वायरस which is happening around the country right now, so virus in progress. I would like you guys to stay at home and stay safe. All right, stay at home and stay safe, like this guy. And crack IIT-JEE with India's largest platform, which is Unacademy. Yes, India's largest online platform currently is Unacademy. So definitely, while you're staying at home and staying safe, crack IIT-JEE with the platform. That's it. Get the plus subscription using the code NSS1 to get 10% off on anything you're taking. Any kind of course you're taking, just use the code NSS1 to get 10% off right away. Awesome. So today is a very special day for Indian cricket team. It's the lowest score India has ever made and the lowest score a team has made in 65 years. यार ये तो स्कोर कार्ड है एक बार I wanted to show you guys how things can fall. So see the best of players, the best of teams can also perform this bad on the main day. So this is what even I want you guys to understand. Even the best of you guys can have bad days like this. Okay. Everyone has bad days just like you, but I want you guys to understand you should not do that in the exam. That is why do have bad days before the main exam starts. Unlike India did. प्रैक्टिस टेस्ट में ऐसा कर लेता तो सेट हो जाता मतलब अभी इस बार थोड़ा आराम से खेलते सो क्यों कर रहा है या हियर इट इज so yeah, so I'd like you guys to learn this from the Team India's performance today, which is get some consistency before you write the exam. All right, that is the main motto you have to understand. Put it in your head after what happened to the this thing. So yeah, about me, I am N Srikanth, guys. As you all know, I did my BTech from IIT Kharagpur. I have an AR of 385. I've been guiding you guys for the last 4+ years. You guys call me human calculator. Well, you'll know why. I'm a Sunrisers fan. It was good while it lasted, and DC is equally marvelous. If you have anything to say about this, hit the like section below and hit the comments and go crazy. All right. So yeah, let's crack. This is Let's Crack JEE channel, given by Unacademy to you guys, especially during quarantine ना जहाँ पे मतलब पूरा दुनिया में कोई नहीं था. One was teaching classes to you guys, and that is where I really felt connected with what Unacademy has done and how it's going forward also. So yes, definitely use the subscribe to this channel. Let's Crack JEE and share these videos everywhere so that everyone who's preparing for the exam can reach out to us and comment and ask for help. And anything you want to ask, just feel free to put it in the comment section below. All right. Hello, Veer Patel. How are you? I hope you're doing good, man. Awesome. Awesome sauce. Chalo. So before we go further, this is something I would like you guys to understand. Don't be like Team India today. Okay. Don't be like cricket team. Don't be like Team India. मतलब पहले से ही थोड़ा मतलब डिजास्टर प्लानिंग करना पड़ेगा. दिस इज व्हाई आई एम ब्रिंगिंग इन टफ क्वेश्चंस फॉर यू गाइस. आई एम गोइंग टू सॉल्व ऑल Irodov and Pathfinder problems which are very tough conditions, just like bowling conditions in Australia right now. बहुत टफ कंडीशन है यहाँ पे. एग्जाम का क्वेश्चंस बहुत टफ है तो आई विल ट्राई टू गाइड यू गाइस टू नॉट बिकम लाइक व्हाट टीम इंडिया डिड टुडे. ऑलराइट, लोएस्ट स्कोर इन 65 years. बहुत मजा आया देखने. So yes, so I'll give you one strategy for that before we go any further on problem solving. The only strategy is keep writing tests every day. Writing tests every day मतलब हर दिन एक एक टेस्ट खुद का रख दो of your own. It's not like टेस्ट मतलब देख टेस्ट मतलब क्रिकेट टेस्ट नहीं है. फर्स्ट ऑफ ऑल दिस एग्जाम्स, राइटिंग एग्जाम मतलब इट्स नॉट जस्ट द एग्जाम दैट दोज गाइस कंडक्ट. हेलो सायराम गारू. हेलो, गुड इवनिंग अम्मा. गुड इवनिंग डैडी. So yes, writing tests every day is very important. Exams. and you make your own exams. It's not like if you don't have any exams, you won't write any exam because sir बाहर नहीं दिख रहे, institute वाले exam नहीं दे रहे. So that's all not what I want you guys to do. You have to write tests of your own where you select random 20 questions, random 20 or 30 questions. जो ऑब्जेक्टिव है तो ऑब्जेक्टिव टेस्ट का प्रिपरेशन हो जाएगा, सब्जेक्टिव है तो थोड़ा मतलब एडवांस का प्रिपरेशन हो जाएगा सिमिलर. बट टेक 20-30 रैंडम क्वेश्चंस एंड पुट 1 hour on stop clock, सब बंद, close the door, sit alone and start writing it. Do it for every subject for 1 hour a day, and you have no clue how much practice this is. This is going to give you time practice. जैसे कि बहुत लोग practice करते हो, you guys, you either take time, don't take time, you just keep guessing. Guys, you either take time, you just. A lot of disturbance outside, so I thought it'll reach you, but thanks to the magic of sound engineering, it's not being audible to you guys. Pretty cool, actually. So yes, random 20-30 क्वेश्चंस ले लो, 1 घंटे में सॉल्व कर लो, बस काम तमाम, रिलैक्स करो उसके बाद. That's it. This is the one major technique I would like to give everyone. This is like practicing for an exam along with practicing for the syllabus. Both of them together. This is like two in one wala. Two in one ho jata. So that is the major advantage, guys. So definitely, if you ask me, go for this. Not only this, and then you have one more thing, like exactly what I told you. Exam JEE का exam is not going to be easy. वो तो बात पक्का है. Exam easy तो नहीं होने वाला है ना. So my second strategy would be to do tough problems. Do tough problems, and then like that is why do tough problems for 1 hour a day. So 1 hour of test and 1 hour of tough problems. These both are very important for you to crack JEE Advanced. अगर तुझे JEE Mains ही करना है तो ऊपर वाला first part if you do, that is more than enough. This if you do for 70 days now, I'm telling you, your performance will increase so much fold. Not your understanding of the subject. That is not what we are after. Because यार तुम्हें जितना पता है बहुत सारे लोगों को वो सब पता है. But what should make you different? What should make you stand out in an exam is what I'm trying to give you guys. तो ये अच्छा लग रहा है तो शेयर करके सब जगह भेज देना इस वीडियो को, ठीक है. एंड एनीथिंग यू वुड लाइक टू से जस्ट पुट इट इन द कमेंट सेक्शन बिलो. यू आर फ्री टू डिस्कस. ऑलराइट, तो ये 70 डे का प्लान मैं आपको दे दिया. सो डेफिनेटली ये फॉलो करना टू गेट लाइक इंस्टेंट, इंस्टेंट नहीं मतलब 70 डे का रिजल्ट 70 डेज में हो जाएगा. डू दिस रेगुलरली एंड यूर सॉर्टेड मैन. सो यस, सो दिस इज another 90 minutes of solutions to Irodov and Pathfinder by me, N Srikanth, to you guys based on your public request. You guys asked for this. तो आज रोटेशन प्रॉब्लम्स नहीं है, आज ग्रेविटेशन बेस्ड प्रॉब्लम्स है. रोटेशन लास्ट क्लास का था, अभी ग्रेविटेशन हो गया. So this is the magic code NSS1. So yeah, what are we waiting for? Let's get cracking, guys. तो आज का प्रॉब्लम्स लिस्ट है इरडो का. अभी तक हम 170 तक कर चुके हैं till now from whatever we had done till now. So today we have a list of 5 questions which are from 190 to 235. 234 number अच्छा लगा तो डाल दिया. And a couple of Pathfinder problems today. I didn't have many Pathfinder problems today because I'm planning to have one more session of exclusive Pathfinder problems in the evening. So definitely stay tuned for that class also. Yes, this is the couple of books we're going to cover. As I tell you, one good problem is better than 100 easy ones. Especially with IIT-JEE exam being the way it is, this is one thing I would like you guys to put in your mind. एक अच्छा problem तुम 10 बार करो, it is much better than doing 100 easy problems. तो हेची वर्मा का लास्ट 10 प्रॉब्लम्स इस टाइप का वाला प्रॉब्लम्स को जरूर कर लेना एंड डेफिनेटली इस वीडियो को लाइक कर देना और शेयर कर देना. तो यस, लेट्स टेक द फर्स्ट क्वेश्चन हियर. अ स्मॉल बॉडी, गिव मी वन मोमेंट गाइस. हियर कुछ नहीं, कुछ नहीं. अच्छा, सब awesome. Yes. A small body of mass m is tied to a non-stretchable string. It's tied to a non-stretchable thread and moves over a smooth horizontal plane. The other end of the thread is being drawn into a hole O. Okay, is said it's being pulled down instead. Find the thread tension as a function of R between the body and the hole if R is equal to R naught at omega is equal to omega naught. R is equal to R naught when omega is omega. And it's coming inside with constant velocity. मतलब इसका मतलब क्या है? अगर at any instant if it is having a radius r, dr by dt will be equal to constant. That is what he is giving us ना. खैर उसको हम कुछ यूज करने का जरूरत भी नहीं है because he is asking us to tension as a distance as a function of distance r. It's not asking us to find a tension as a function of distance as a function of time. वो अगर पूछता तो क्वेश्चन थोड़ा बदल जाता but he since is asking a very simple question just based on r, it's a simple calculation. Here one thing we know, the force is centripetal. The force which is acting which is pulling it downwards is centripetal. Centripetal का मतलब mv square पे r नहीं है. Centripetal means it is acting towards center. तो मतलब ये टेक्निकल मीनिंग से मैं चल रहा हूँ कि इट्स द मीनिंग ऑफ सेंट्रिपेटल हियर इज इट्स एक्टिंग टुवर्ड्स सेंटर. तो इसका एक्सेल इसका फोर्स मैं अभी ये नहीं करूँगा. Since the force is centripetal, it does not produce any torque. This does not produce torque. These are the couple of very important points you can analyze by solving it and by understanding the question. Force is centripetal, which is acting towards center, and the second thing is it does not produce torque because it is central. Because it is centripetal. मतलब centripetal force हमें always पता है, it does not produce torque. So what can we conserve here? When torque is equal to 0, it means dl by dt is 0, which means L is conserved. L क्या है यहाँ? Angular momentum. So one thing we know, when torque is equal to 0, angular momentum will be constant. This is only called conservation of angular momentum, जो already पढ़ चुके हो. तो we'll apply this here on this little cute looking sub problem. कुछ नहीं हुआ दोस्त. चलो let's go. Let's get solving this. हाँ. So what is the initial angular momentum here? Red में हो गया automatically. Initial angular momentum here is, we know generally it's r cross p, or you can also say I omega or r. So either ways, if I just want to find the magnitude, I'll write it as m into omega, m r square into omega. Getting it? So mr square omega is the angular momentum. So this formula में if I apply the initial condition is where omega is omega naught and radius is r naught. तो इनमें से क्या हो जाएगा? Initial angular momentum will be m r naught square into omega naught. And what is the final angular momentum? At a distance r, he's asking us to find omega. What is the function of r? He's asking us to find something as a function of r, no? Angular velocity is a function of r. Tension, ठीक है. So at t at radius is equal to r and velocity is equal to and angular velocity is equal to omega. What is the angular momentum? It will be m r square into omega. By equating both of them, we can say m r naught square omega naught will be equal to m r into omega. So we want everything in terms of r. That is the main point of the question, right? Everything we have to solve in terms of r. So ये omega को भी I'll find out in terms of r. What is the omega using this equation? Equation 2. M r naught square into omega naught by m r square. ये हो गया. This is the omega as a function of distance. Now, what is asked? We found out the omega in terms of distance r. What is the tension in the thread? Tension in a thread is nothing but the centripetal force it is causing. It is only the centripetal force, and it is equal to m into v square by r, or it's also m omega square into r. So this is the tension as a function of uh, omega and radius. All right. तो इसमें टेंशन का वैल्यू कितना, just substitute the values now. We know omega in terms of r is also there in terms of r, and mass is also there. It's a constant. So now we just substitute all the values. थोड़ा वाइट हो गया ना, येलो डालते हैं. टेंशन हो जाएगा m into m r naught square omega naught by m, ये mm cancel हो गया, by r square whole square into r. If I this is m into r naught power 4 omega naught square into r by r power 4. तो इससे क्या आ जाएगा, टेंशन इज इक्वल टू m r naught square r naught power 4 into omega naught square upon, this is the final answer guys. मतलब दिखने में, बस सिर्फ दिखने में बड़ा है ये. इट्स अ वेरी सिंपल प्रॉब्लम. I hope it's clear to you guys. Any doubt you have, you can put into the comment section. We'll follow up later. All right. So now, this has always been a very fascinating question. Generally, when there are when there's a free moving, rotating a dumbbell along with a mass, when a body is hitting a scale or when body is hitting a couple of masses together, placed connected by thread. These kind of questions are generally, they involve so much mechanics that a question like this can help you understand the entire thing in one. That's why I brought this question down to you guys. A ball of mass capital M, the ball of mass capital M, is moving with a velocity v naught, experiences a head-on elastic collision. यहाँ पे it is undergoing an elastic collision. यहाँ पे E is equal to 1. Okay. With one of the spheres of a stationary rigid dumbbell as shown in the figure. The mass of each sphere equals m by 2. तो एक बात पक्का है, यहाँ पे दोनों को मिला के the total mass is again equal to m. ठीक है, इन दोनों को मिला के total mass is again equal to m. The distance between them is L. Disregarding the size of the spheres, find the proper angular momentum of the dumbbell after the collision. It asks us to find the angular momentum after collision. All right. तो इसके लिए बस न्यूटन्स लॉस इक्वेशंस और रोटेशन इक्वेशंस दोनों को मिला के E is equal to 1 का इक्वेशन से मिक्स करो, आंसर हो जाएगा. Because it contains one thing you know, all the forces here are internal. ठीक है, everything when the capital M mass strikes the small m by 2 mass, बाहर से कोई पुश नहीं कर रहा. There's no one at all pushing or disturbing anything of this sort. So we can clearly assume that the total linear momentum will be conserved. This is the first and foremost thing we have to keep in mind. Right? Got it? The total linear momentum is conserved. Now for the second part of it, linear momentum के बाद और क्या है यहाँ पे? About the center of mass, if you observe, let's take center of mass of the dumbbell. I'm taking center of mass of dumbbell because there is an impulsive force which is hitting these both. I'll come to that point as we go. But पहले देखो, about the center of mass of the dumbbell, initial angle, there is no external torque. About center of mass of dumbbell, external torque is zero. तो इसका मतलब क्या है? When the external torque is zero, it means that angular momentum will also be conserved. Thus we can say that angular momentum is also conserved. Wow. Cool. So angular momentum is conserved hai, linear momentum is conserved hai, and what is the other equation we are going to write here? It is a perfectly elastic collision, which implies E is equal to 1. This is the third kind of. Alright. So let's put all these three into perspective then. Yes. Alright, got it. So yeah, let's go for this then. The total linear momentum is conserved. Let's take the final situation. Initially क्या दिया हुआ है? This is m having a velocity v naught and these two dumbbells are at rest. अब after collision हो जाता है ना collision. So after collision, let's take this velocity to be some v1. ठीक है. और इस डम्बल वन थिंग यू नो यहाँ पे डम्बल को टॉर्क मिल रहा है बट देन दैट डम्बल इज गेटिंग द टॉर्क बट द एंगुलर मोमेंटम ऑफ द मास m is decreasing, hence the total angular momentum will be conserved but individual the dumbbell will start rotating. So let's take the condition here that this is rotating about center only or क्या rotating with center with omega and the center is having a velocity of v. Okay. So, because center means center of mass, I mean this is about center of mass. So, center of mass ke across, these are the two things which are going to happen. And one thing we already wrote down, the linear momentum will be conserved. So, let's start writing equations. Writing equations of the above three statements. The first thing is conservation of linear momentum. What is the initial linear momentum of the system? P initial will be equal to mv naught and P final will be equal to mv1 plus velocity of center of mass of the dumbbell is v. So I will write it as m. इन दोनों को इक्वेट करने से क्या आ जाएगा? We will directly get v naught will be equal to v1 plus the first and wonderful equation. Yo, cool man. So v naught is equal to v1 plus v. So what else? What all do we have now? This body is going with a velocity of v1. Dumbbell is rotating with omega and also having velocity v, and we also know v naught is equal to v1. Now let's go forward. Next thing is angular momentum. What is initial angular momentum? It is r cross p, as we all know. About the center, I'm taking angular momentum about center of dumbbell. Okay, so initial angular momentum कितना है? The particle is at a distance, मतलब if you draw the moment arm, the length of the moment arm is L by 2. For this, r perpendicular is equal to L by 2 and momentum is equal to mv naught. तो इससे सीधा angular momentum आ जाएगा is equal to mv naught into L by 2. The first question. The final angular momentum will be one is due to the mass already and also the rotation of the dumbbell. It is one due to mass m, which will be equal to m into v1 into L by 2. क्योंकि ये यहाँ से समझ में आ गया ना, it's mv naught into L by 2. So I use the same logic again. I will put in mv1 into L by 2 plus moment of plus the angular momentum of dumbbell. ये डंबल का मोमेंट एंगुलर मोमेंटम कैसा होगा? It is I omega, simple. So for dumbbell, you have to first understand what is the I of a dumbbell. I of the dumbbell will be equal to m into L by 2 whole square taken twice. Because two bodies are there, two bodies, each of mass m by 2 at a distance L by 2 from the center, multiply twice. इससे कितना आ जाएगा? ml square by 4. Wow, okay. L square by 4. So yes, now we can directly write the equation saying mv naught into L by 2 is equal to mv1 into L by 2 plus ml square by 4 into omega. यहाँ पे m सब जगह कैंसिल कर दो, L को कैंसिल कर दो, v नॉट विल बी इक्वल टू v1 प्लस ओमेगा L by 2. ये हो गया दूसरा इक्वेशन. इफ यू लिंक बिटवीन फर्स्ट एंड सेकंड इक्वेशन यू विल डायरेक्टली गेट वेलोसिटी विल बी इक्वल टू ओमेगा L by 2. Is using 1 and 2 because any only thing it's changing is velocity v and omega L by 2. तो ये मस्त वाला इक्वेशन, ये दूसरा वाला भी आ गया. Now for the third one which we discussed already is one is linear momentum, one is angular momentum, and the third is collisions. अब collision का एक और पेज देना था. Hey, let's go. अब सीधी सी बात. Collisions will not depend on frame, it will only depend on line of impact, right? यहाँ पे एक बड़ा सा एम मास आके यहाँ पे इस डायरेक्शन में मार रहा है. So what is the line of action, line of impact? This is the line of impact as we see it. So before it is going with v naught, so which means speed of approach is equal to, after collision along the same line of impact. If you see, this body is going forward with v, this dumbbell is rotating with it's going with v as well as rotating with omega. So iska velocity will be how much? By using the rolling logic, it will be v plus omega L by 2, which is in fact equal to 2v, because we just derived v is equal to omega L by 2. So 2v आ गया. So speed of separation is how much in this case? It is equal to 2v minus v1. What is asked in the exact question? Angular momentum ना. तो इसको हम ओमेगा में लिखते हैं. चलो ठीक है. Is equal to omega L लिख दो, because v is omega L by 2. So here also we will end up getting omega L minus the speed of separation. And from equations we know v naught is equal to omega L minus v. से क्या आ गया? ओमेगा L is v naught plus v. ये मतलब equation. What are the three equations we got? V naught is v1 plus v. बाकी सब हो गया. Think about it. Omega L minus v1 is. अच्छा, ये दोनों को एक बार लिंक करो. जस्ट इक्वेट इक्वेशन 2 एंड इक्वेशन 1. इसमें आंसर आ गया. v नॉट इज इक्वल टू ओमेगा एल बाई टू. बस सीधा पीछे जाके देखो. ओमेगा एल बाई टू विल बी इक्वल टू v नॉट माइनस v1. ये हो गया द सेकेंड इक्वेशन. दोनों को ऐड कर दो या कुछ भी कर दो, सीधा आ जाएगा आंसर. So when you add this, you will get 3 omega L by 2 is equal to 2 v naught. That's it, guys. This is what we wanted. Finally, 3 pages of extensive equation writing and we are done with this. So इससे क्या आ जाएगा? Omega L is equal to 4 v naught by 3. And angular momentum is m is I omega, which is equal to ml square by 4 into 4 v naught by 3. तो इससे क्या आ गया? 4 v naught by 3l. इससे क्या आ जाएगा? Which is equal to m v naught L by 3. And as per the diagram, it is rotating in clockwise direction, because by logic of collision in this particular question, the body will start rotating in clockwise, which will make the direction minus k. There you go, guys. Wow, that's a great question and a great solution. Now for the next question. A double star is a system of two stars moving around the center of inertia of a system due to gravitation. The double star क्या है? It's very commonly found in the across the universe. In fact, most of black holes have been figured out by using their double star as a reference. मतलब, they'll actually calculate where the black hole is based on how the adjacent star is moving along with it. It's a very crazy thing. You have to check a lot of videos on it. Pretty cool. Next, find the distance between components of the double star if the total mass of the system is m and the period of revolution is t. तो देखिए यहाँ पे क्या है. There is one m1 ले लेता हूँ. There is one छोटा सा m2. So both of them will rotate about a certain axis. Right, they are rotating about a certain axis due to mutual gravitational force. Okay. Let's take the situation like this. यहाँ पे एक बड़ा सा मास ले लो. बड़ा सा मास, इसको m1 ले लेते हैं. एंड एक छोटा सा मास लेते हैं. अबाउट सेंटर मतलब सेंटर विल बी शिफ्टिंग. मतलब very bad. Center of mass will be somewhere here. So how will this body rotate? This body will rotate in a circle which is moving like this. and this body is moving in a circle like this. Yes, that's it. Okay. This is how the M2 mass will rotate, and this is how the M. So what are we asked to find? Find the distance of separation between both these bodies. So this is what we are supposed to find. This is what we are set to find. So इसको कुछ R ले लो, and let's take one body is closer body, just because it's closer I'm taking separation to be D. इसका separation D ले लिया मैं, इसका separation R दे दिया. So I'm also asked to find R. Thanks. Thank you. Yes. So we have to find the total distance R here. ठीक है. We know one more. What are the values which are given to us? Let's just analyze. The total mass is given. So let's take m1 plus m2 will be equal to total mass. And time period of rotation is generally what? It is nothing but 2 pi by omega, right? Time period 2 pi by omega is equal to time period. These are the two things which are given to us. ठीक है. Now, इसमें क्या the concept of two star system is both of them are moving in circles about center of mass. मतलब both of them will move about center of mass. Center of mass वहीं पे रहेगा because there is no external force acting on the system. So one particle if there is on the other end, the other particle should be exactly the diametrically opposite position. Diagonally opposite position. So if one mass is at the top on the north direction, the second mass should be exactly at south. If one is in the east, the other should be at the west. So that's how they both move. They move diagonally opposite. Both the bodies move. Celestial bodies, stars, in diametrically opposite points about center of mass. So this is one way of understanding it. Why now? मतलब नहीं तो if both of them are moving towards each other, then center of mass will start shifting. ठीक है. अब center of mass shift नहीं करना है तो क्या होगा? They both should be at same distance from each other and they should be rotating exactly about the center. ठीक है. Okay. So that's the main concept here. So center of mass के about equation लिख दो. So if both of them move exactly in diametrically opposite points, both will have same time period. Both will have same time period. They will have same omega मतलब भी time period. They will have same force experienced. They'll because they're equal and opposite forces. It's gravitational force. So it's equal and opposite on both of them. ये तीनों same है. What is different? What is different इसमें सोचो. One thing, acceleration is different because masses are different. Okay. And speed is different because the distance is different. The path is different. Only thing is that they are diagonally opposite. So these are the sames and these are the not so same. All right. So this is one and this is the other part. So let's start equating both of them first. What do we know about forces? The force acting is equal to G m1 m2 by the total separation between them, which is equal to R. Now this force causes circular motion. So as we see here, we took the mass m1 to be reference, right? It causes circular motion of m1 in a radius of d. Radius. तो इसमें क्या बोल सकते हैं? gm1 m2 by r square should be equal to m1 into omega square. What is the acceleration here? Omega square r. You can always write it that way. So I will directly write it as m1 omega square. तो इससे क्या इन्फरेंस आ जाएगा? gm1 m2 by r is equal to m1 omega square d. This is the first equation we're getting, right? Here. All right. Now for the second part of it, इसको कैंसिल भी करेंगे थोड़ा, मतलब नहीं कि ऐसे ही छोड़ दी. Equal to m1. And what is the value of d in terms of r? That is the next point. तो अब एक स्टार को फिर से खींच लो. This distance is d and the total distance is r. हाँ ठीक है. हाँ ठीक है. But one. हाँ ठीक है. All right. So this total distance is r. This mass is m1. This mass is m2. This is center of mass. तो ये distance कितना होगा? The distance d can be written as m2r by m1 plus m2. Because ये origin ले लो. Simple ways you think about that as origin. At m2 at r distance there is m2 mass. So center of mass will be at m2r by m1 plus m2. Simple. You can substitute this here now. You will get a much more comprehensive clarity होगा थोड़ा. थोड़ा तो बढ़ेगा. And you will also come across a formula which we derived in Kepler's 1 omega m1 into m2 into r by m1 plus m2 into omega. So this if you observe, मतलब यहाँ पे ये m1 m2 by m1 plus m2 जो आया ना, this is also called as the combined mass. This is most commonly used when there are multiple stars, when you want to find out the force of attraction relation between that and the acceleration of the bodies. Combined mass is generally defined as m1 m2 by m1 plus m2. When two masses m1 and m2 are moving because of mutual forces, this is what will be the equivalent of the total mass which is acting. Like you can take the whole system to be a single mass, having this as its mass. अब इनको सॉल्व कर लो, ये दोनों कैंसिल हो जाएंगे. वाह यार काफी सिंपल हो गया. g by r square is equal to omega square into r by m1 plus m2 कितना है? m1 plus m2 r cube is equal to gm by omega square. ठीक है. And what is omega here? We already know omega is 2 pi by time period, because time period is 2 pi by omega. Substitute this here, we will get 4 कर देते हैं. Putting this in equation 4, we are getting r cube is equal to gm by 2 pi whole square. से क्या आ जाए? r equal to gmt square upon 4 pi square whole power 2. So is this what the solution is? Is this what it's asked? Yes guys, this is the answer. Power 1 by 3. So there you go guys. Hello Yankatesh, hi. So this is the solution for the next one. Chalo, now for the next question guys. 1 minute रुको. हाँ, ये क्वेश्चन एक है जिसका सॉल्यूशन में I'm going to give you a different. It's not what is given in the Irodov book. Traditional solution नहीं दे रहा हूँ. I'm just going to give you the concept here because it's a something you have to understand more than remember the big value you're getting. इसमें मतलब एक एक पेज का पूरा एक लाइन का सॉल्यूशन है, पता है, मतलब एक लाइन का आंसर है, नॉट सॉल्यूशन. Not going to do the whole thing. I just want you guys to understand how to solve this. Then we can go to the next. A planet A moves in an elliptical orbit around the sun. Elliptical orbit है क्या है उसमें? Sun at one of the foci, Kepler's law sub तो पता है ना? Sun is at one of the foci. This is the closest approach. This is the farthest approach. At a particular time, it is moving like this. Okay. Distance when the sun is at r naught distance from the sun, its velocity was close to v naught. A velocity v naught है, and the angle between the vectors was equal to alpha. Okay, the angle between the two vectors is alpha, and velocity is v naught, and the radius vector is r. The velocity v naught was equal to alpha. Find the maximum and minimum distances that will separate this planet from the sun during its orbital motion. मतलब क्या है इसमें मैक्सिमम और मिनिमम डिस्टेंसेस कैलकुलेट करना है, दैट्स ऑल नो. चलो चलते हैं. सो व्हाट डू वी नो अबाउट दिस? ग्रेविटेशन में क्या क्या है दैट यू शुड रिमेंबर बिफोर वी गो अप्रोच दिस प्रॉब्लम एट ऑल. द फर्स्ट थिंग इज ग्रेविटेशनल फोर्स इज सेंट्रल. मतलब बहुत जगह यूज होता है यार. ऑल दिस सेंट्रल फोर्सेस ना, दे आर जस्ट वर्ड विच विल जस्ट make you solve everything in terms of angular velocities and angular momentums. Gravitation is a central force. So these kind of forces, like even electrostatic forces, they don't produce torque. So anytime you solve any problem, you can just first write off the equation of angular momentum and solve. That will help you in a lot of ways. It's just simplifying it. That's all. Gravitation is a central force, so it does not produce torque. Angular momentum is conserved, right? Conserved. Find the maximum inverse distances that will separate this planet from the sun during its orbital. That will तो ले लो ये at this point इसका velocity b ले लो, 1r1 ले. तो इससे क्या हो जाएगा? What is the initial angular momentum? mvr ना. तो for a particle of mass m r naught, the initial angular momentum will be even the angle between the two vectors. So cross product है, so it will become mv. r cross p का logic, which is also equal to rp sin alpha. r है m, r है r naught, and p है mv naught. And finally, at extreme positions, so one thing we know, if the position is not extreme, मतलब इस सेट जाए उस सेट में नहीं है, whenever it is like that, the angle between r vector and the velocity vector will not be 90 degrees. It will be 90 only in these two conditions, when one at the apogee, one at the perigee. Apogee is the closest and perigee is the farthest away. So the angular momentum will be uh, equal throughout, but momentum will be perpendicular to the radius vector only at two places. Momentum is perpendicular to r vector only at 2 points. Yeah, so that's how it is. So at extreme positions, so angular momentum find out कर लेते हैं. Let's take at this position the radius is r1 and velocity is v1. So L final will be equal to m into v1 into r1 into sin 90, since we know it is perpendicular. This value will come out to be mv1 r1. So इन दोनों को equate कर दो by using conservation of angular momentum. What are we getting? ये दोनों cancel हो जाएंगे. v naught r naught sin alpha will be equal to v1 r1 is equal to v naught r naught sin alpha. ये हो गई बात. So next, what is the other equation we can actually write in this particular situation? The total energy of the system. Total energy of the system will remain constant also. मतलब यहाँ पे जो काइनेटिक एनर्जी पोटेंशियल एनर्जी है, यहाँ पे काइनेटिक एनर्जी पोटेंशियल एनर्जी है, दोनों का वैल्यू सेम रहेगा. We have to find the distance of shortest approach, so we have to find distance. So मैं क्या करता हूँ? Distance चाहिए, तो what will I do? I will just convert velocity into distance form. Velocity as a function of distance, so that I can use this everywhere. What is the original solution we got? V naught R naught sin alpha is equal to V1 R1. इसे V1 क्या आ जाएगा? V naught R naught sin alpha by, तो V ले लेता हूँ बस, R लेते हैं. तो second equation we have. One is after using conservation of linear angular momentum, I am going to use velocity in the energy equation. Now I will use conservation of mechanical energy because no other force is doing any sort of work, only gravity is just pulling on the planet along its own elliptical orbit. So we can use conservation of mechanical energy. Initial momentum, so kinetic energy will be given by half m v naught square. Potential energy initial is given by minus gmm by r naught. Very important point here. R naught hai. Finally, it becomes very random, guys. That is where we most of we have an issue. Most of the times have an issue. Finally, kinetic energy becomes half mv square, and potential energy becomes minus gmm by r at this particular point. And I can also already find velocity as a function of r here. So that one I will substitute right away first. What will I get? Half m v naught square minus gmm by r naught. ये तो पूरा जगह constant है. If you observe carefully, the entire thing is a constant. So इसको we will not be changing it at all. We will just substitute the whole values of whatever we got. Velocity in terms of r तो ये होगा v naught r naught sin alpha by r whole square minus gmm by, this is the equation, guys. So if you look into this equation further, what is it we are getting here? Half m v naught square minus gmm by r naught. I will take it to be equal to c. Okay, the first thing. The best way to solve it is by converting everything into simple this thing. So half m into v naught square sin square alpha into r naught square on r square. This is one of the other the right hand side. This is the right hand side, right? Minus gmm by r. This is the right hand side. So right hand side में I will just convert everything into one particular value. So I will write half m v naught square sin square alpha into r naught square is equal to b, and minus gmm is equal to c. ठीक है, gmm is equal to c लिखता हूँ. So what am I getting? LHS में क्या है? Constant will be equal to b by r square minus d by r. What kind of equation do we get here, guys? B by r square minus d by r is equal to constant. इसका मतलब क्या है? तो इसी से आंसर आ जाएगा हमें. तो just draw the diagram of how this works. ये b by एक 1 by r कॉमन ले लो बाहर. by r minus फर्स्ट वाला solution आया. This is equal to constant. That is what is given here. So for this to be a constant, this should not be zero for sure. वो बात तो पक्का है. और क्या कर सकते हैं? We'll just send this to the other side. Oh, इतना the whole thing with r square. Okay, over c r square is equal to b minus dr. से क्या आ जाएगा? सी आर स्क्वायर प्लस डी आर माइनस बी इज इक्वल टू जीरो. इसका सोल्यूशन क्या है? सो द पॉइंट इज दिस शुड बी इक्वल टू जीरो. Okay, there is no other going back, and it is only perpendicular when the other angle is zero. The other angle is 90 degrees. जैसे कि हम already discuss किए. So the solution of this will be the answer. तो ये बहुत लंबा आएगा, but we actually simplified it much smaller than how it actually looks outside in the solutions or answers. तो इसमें r कितना हो गया? माइनस सी प्लस रूट ओवर सी स्क्वायर प्लस 4bd माइनस डी ना. तो दिस इज द वैल्यू गाइस. तो मतलब यहाँ पे if both of them are subtracted you will get r max will be equal to root of c square plus 4bd plus d upon 2c. R minimum will be equal to root of c square plus 4bd minus d. तो इसमें याद रख लो where the values of c is this, b is this, and d is this. So I hope you understood this now. Okay, so yeah, now let's get going to the next question. A thin uniform rod AB of mass m is 1 kg moves translationally with acceleration of 2 meters per second. Okay, acceleration of the center, acceleration of the system is 2 meters. Happy. So next, two anti-parallel forces F1 and F2. Okay, they are acting opposite to each other. Happy. So the distance between the points at which these forces are applied is equal to 20 centimeters. Acha, they are having a difference in r perpendicular moment r, which the difference between the moment arms is 20 centimeters. ये दे दिया. The distance between these 2 points is 20 centimeters. All right. Besides, it's known that F2 is nth of 1 and family is 5 newtons. We have to find out the length of the rod. 2 is given, find length. Mass is given. यार सब कुछ दे दिया है यार इसमें. First one thing we know that the body is translating. If it's only translating, what is the meaning of it? What is the meaning when it's only translating or going forward? It means that the body is not rotating. Translation is just the synonym of antonym of rotation. So it is not rotating, hence it's translating. So here I will apply Newton's laws of motion. I will say F net will be equal to mass into acceleration. F net कितना है इस body का? F net is F2 in the forward direction, F1 in the backward direction. So if you observe, since the body is translating, there is no torque, which means the one which has lesser moment arm will have more force. So by logic, I can say the force which is closest to the center will be more. By logic, I can say F2 is greater than. So net force कितना हुआ? Net force is F2 minus F1 is the net force. Newton's law F net is mass into acceleration, so इससे क्या आ जाएगा? F2 minus F1 is equal to 1 into acceleration 2. तो F1 का वैल्यू दिया हुआ है कि F2 is already given as 5. F2 is already given as 5 newtons. So F1 will naturally be how much? 3 newtons. 5 minus 2, which is 3 newtons. This is the first value of force we found. These are the two values of forces. Now the second part of it, what are we supposed to find? We find the length of the rod. So one thing we know, the body is only translating, which implies no rotation. So rotation के बिना मतलब मजा नहीं आएगा, but then that's why the problem is little easier than the other. तो यहाँ पे है, ठीक है. On this side there is one force F2. On this side there is force F1. What is the condition that they both will net torque will be zero? तो ये length L ले लो. Torque due to F1 will be F1 into L by 2 because L by 2 is R perpendicular, and torque due to F2 will be equal to F2 into L by 2 minus A. And since both of them are equal in magnitude, we can link them saying F1 into L is equal to F2 into L minus A. सब्स्टिट्यूट कर दो. You have to find L ना, तो L क्या आ जाएगा सीधा. So you have to find L. So what will I get? F1 F2A is equal to F2 minus F1 into L. So L हो गया F2A by F2 minus F1. Substitute the values, we'll get the answer, which is F2 is 5 into A, separation is 0.2 meters by F2 minus F1. तो इससे क्या आ जाएगा? You will get the answer to be 1 by 2. One minute. Your value of F2 is how much? F2 is 5, 1 is 3 newtons, acceleration is 1. तो पॉइंट टू क्या डालते हैं? अच्छा, ये एक्सेलरेशन, ये लेंथ कितना दिया हुआ था उसमें? 20 सेंटीमीटर. 20 सेंटीमीटर में 0. तो दिस इज इट गाइस. सो इससे लेंथ क्या आ जाएगा? हाफ मीटर आ जाएगा. रॉड मीटर में ये 20 सेंटीमीटर नहीं होगा. नहीं यार, यहाँ पे 2 ये मतलब मल्टीप्लाइंग बाई 2 दिस हो. 2 ये भी हो गया, इंटू 2 भी हो गया. इससे क्या आ जाएगा आंसर? 10 into 0.2 which is equal to 1 meter. Length of the rod is actually equal to 1 meter only. So I hope you understood this, guys. If you are liking this, share this everywhere so that everyone in the world can see this. Yes. So while you're sharing it, crack IIT-JEE with India's largest platform, which is Unacademy. Get the plus subscription using the code NSS1 and access unlimited live and recorded courses. So what do you get with this subscription using the code NSS1? मैं बोल रहा हूँ NSS1 code है. All these things. What is the main advantage of having this code? What is the main advantage? So plus subscription, you get daily live classes. You get daily live classes where you can chat with your educator, engage in discussions all while the class is going on. मतलब एकदम dynamic interaction रहता है. Unlike this place, यहाँ पे थोड़ा delay रहता है. But in the Unacademy app and in the plus subscriptions classes you get daily live classes where you can discuss in direct, मतलब head to head discussion चलेगा मस्त. Like college का simulation रहेगा. Not only that, you have live tests and quizzes where your preparation with regular mock test quizzes, and you can get detailed analysis of your performance, and you get structured course. Like on outside colleges, when you miss a day, you are just lost. So in that kind of situations also, you have a very structured pattern here in the plus subscription, which will help you with covering up what you missed so far, or which will give you very good clarity about how to prepare. Is the exam. And you get unlimited access to all the teachers from across the country. मतलब पहले ऐसा था ना कि if you had to study or chemistry you had to go to कोटा. बहुत फेमस था. और मैथ्स के लिए नारायण बोला रामे जाना था. मतलब it's all very meticulous. But now everyone's there on the app, and it's a pocket library you have in your access. So it's crazy. And what did Joker say in the movie Dark Knight? When you're good at something, don't do it for free. That is why Unacademy is charging a nominal fees of 38,500 for 1 year. Now you might think like, यार 38,000 बहुत ज़्यादा है. But if you use this code NSS1, that is anyways there, you'll get it for under 35k, 34,650 because you're getting an extra 10% off. Not only this. So the main thing, hello Vijay Lakshmi, Vijay Kumari. Ah, all right. So where was I? Yeah. So this might look big in the beginning, no? But let me tell you one secret for preparing for JEE or any competitive exam is daily prep. It's not like you have to sit one day for 20 hours and then chill out for the next 20 days. That's not how JEE exam or any competitive exam writing works. So you have to do it daily. And if you are preparing daily for one full year, the cost of this will actually come down to 32 rupees per day for physics, chemistry and maths. अब 32 रुपीज पर डे में ट्यूशन भी नहीं मिलता है. चॉकलेट भी शायद एक दो चॉकलेट ही मिलेंगे, ज्यादा नहीं मिलेंगे. So that's how cheap it is. It might sound big, but then That's why I felt it's all right to take the subscription here. Definitely go for it. Those who are cracking JEE in 2022 and beyond, it's all there is also a 2 month course, 2 year course. 2 year course costs out to 56,000 only. After using the code, you get it for 50K. 50K में 2000 का 2 साल का classes चलेंगे इसमें, which is pretty awesome. Yeah, the price is 23 rupees per day. Kinder Joy भी नहीं मिलेगा, so go for it, guys. Okay, not only this, especially in this quarantine time, I know how much most of your students want to want to take the help of teachers. I know how many students have been. I totally understand you guys, but that is everyone is busy with their own life, right? Everyone, even the teachers are busy, even you guys are busy, and there's no classes going on where you can actually come and ask. That is why Unacademy has launched this iconic subscription where it will take your IIT-JEE preparation to the next level with a personal coach. He will give you one-on-one guidance. The top examiner will give you one-on-one guidance and will help you align your preparation strategy. In-depth test analysis will be done, and a study planner will also be given to you based on how you are preparing and how the flow is happening. All this will give you a very positive loop with which you know exactly how much to study and what to study, what your strengths are, what your weaknesses are. If you understand yourself better, only then can you understand the exam better. So this personal coach is there only for you to understand the exam and understand yourself. So not only this, you also get all the benefits of less along with this. All right. The cost of this is for 12 months is 65,000. But if you use the code NSS1, it comes down to 58,500. And a 2 year course for 1 lakh, use the code and you get 10,000 off, guys. मतलब 10,000 का discount मिलने वाला है उसमें. So it's pretty awesome sauce if you ask me. So go for it. All right, now for a couple of very awesome Pathfinder problems. Today I'm doing Pathfinder case subjective problems. Yes, an almost inertial is plank. The plank को moment of inertia almost नहीं है. Yes. బాగుంటుందా నెక్స్ట్ కొనద్దు అయితే బ్యాగ్ నైస్ అర్జున్ నేను 10 minutes లో వస్తా నేను 10 minutes లో వస్తా ఏబీసీ అవుతాను 10 minutes లో వస్తా వస్తా 10 minutes చెప్తా చెప్తా that's a cousin, that's my cousin out there. So all right, an almost inertialess plank we can rotate about a stationary horizontal axle O. This is the axle here, it's rotating about the axle O. Its end B rests on a platform where a small block of mass M is placed on it at a distance L from the axle as shown. यहाँ से L distance पे axle पे लगा हुआ है. The bead of mass m0 is dropped from a height h0, hits the platform near this set A at a distance L0 from the axle. ठीक है. If all the collisions are perfectly elastic, every object is perfectly rigid, find the height h to which the block will jump. ये ब्लॉक का हाइट कहाँ तक जंप करेगा, that is the question. All right. So इसके लिए we have to know the velocity with which it bounces. We have to know the velocity with which it bounces. Up, if you want to analyze this diagram before we go any further, one thing I want you guys to understand is about the center, about O, at that particular state, this particular state, the ground here will not be in touch. This ground will not be in touch, which means the system is almost floating before it goes up. And we can say the total angular momentum, so the total torque given, I want you to understand it thoda simply or explain. So let's see. The impulse given here will produce torque due to impulse. Torque due to the impulse on side A will cause movement in side B. Got it? At So this is the main condition. Torque due to impulse on side A will cause motion at B. तो इसको एक बार if you observe carefully, since it's given that this plank is almost massless, ठीक है, तो यहाँ पे let the ball is coming down with a velocity v naught एक ले लो, and it is, let's say it's bouncing up with a velocity v1, and at the same time there is sudden impulse here which will make this particle here go with some velocity v. Right, Gautam? Gautam? So the impulse here causes this impulse, right? So this and this together, the net torque due to this will be equal to the net torque due to that. Since the plank is massless, since the plank is massless, we can just take that initially the particle is of mass m naught is falling down with v naught ले लेते हैं. We don't care about what it is. We only know that v naught is equal to root 2. ये eventually काम आएगा. We will keep using this final. So the point is, if you leave values in simple equations, it will become easier to solve. That's why this corner of this situation. All right. So यहाँ v naught से bounce हुआ, उसके बाद it's coming down with v naught and it's bouncing up with v1. And this entire plank, since this is going up with v1, implies that this will also rotate with an omega in this particular fashion. All right. So this will rotate in such a fashion, since यहाँ पे it's going up with v implies this omega will be equal to v by n. Okay, this is the second equation I am going to use. That since the body is rotating, this will go up with v. Then that implies that the body should also have an omega which is related to v as omega is equal to v by l. Or we can also say v is equal to omega is equal to v by l better because. And now the second condition in this question. The second condition in this question is that it's a perfectly elastic collision. तो impulse का equation बाद में लिख देते हैं. We already got this. Second thing we know, it is impulse equation. The impulse equation we already wrote off. The torque net will be 0. And the third point is elastic collision. Elastic collision implies that at A, speed of approach will be equal to speed of separation. We'll use these three concepts to just crack this problem. The problem is very, looks complicated, but then काफी simple है. इसका velocity v है, तो ओमेगा कितना हुआ? ओमेगा तो हो गया v by l. So how will this part of this body rotate? It will come down with a velocity of omega into l1. ठीक है, because the length is l0. Omega into l0. ठीक है. This will go with omega into l0. So this part will go with, and this body is bouncing up with velocity v1. तो अब दूसरा वाला e का इक्वेशन लिख देते हैं. E is equal to 1, which implies speed of approach कितना है? v0. And speed of separation, ये नीचे जा रहा है, वो ऊपर जा रहा है, तो it will be equal to v1 plus omega l0. These are the two things. और v1 can be written as v by l. तो इससे क्या आ जाएगा? v1 plus v l0 by l is the speed of separation. ये क्या हुआ? v0. हाँ बस सिंप्लीफाई नहीं है. Now for the second part, we will use the impulse concept. The impulse given here will be equal to the impulse given there. यहाँ पे impulse कितना है? The ball is coming down with v0 and it's next bouncing up with v1. So impulse on the first side, on A side, will be how much? Particle of mass m0. m0 is initially having v0 and finally is having v1. This is the impulse. So angular impulse, so this is the impulse j. So angular impulse, so j angular will be equal to m0 v0 plus v1 into l0. Yeah, this is it. And final angular impulse on B side will be equal to m into v. So impulse angular will be equal to mvl. तो इन दोनों को भी इक्वेट कर दो. वी नो वन थिंग, v नॉट इज इक्वल टू v1 प्लस वी एल नॉट बाई एल. ठीक है, और दूसरा इक्वेशन ये क्या हो गया? m नॉट इंटू v नॉट इंटू एल नॉट, mv नॉट एल नॉट प्लस m naught v1 L naught is equal to mvl. This is the second equation we have. And the first equation, when I multiply with L, I will also get v naught into L minus v1 into L is equal to vl naught. Okay. So इसमें I have to solve these both and I can eliminate one of these values. If I find v, I am done. So I have to eliminate v1 here. So let's write the two equations again, my friends. Just give me one moment. We are going to write this equation again. M naught V naught L naught plus M naught V1 L naught is equal to MVL equation. The speed of approach into L is equal to speed of separation, which is equal to V1 into L plus V into L. This is the value, guys. These are the two values. So इसमें मुझे क्या निकालना है? I have to remove of the v's. तो इसको ऐसे करके लिख सकता हूं मैं, so that I can remove all the v's. I'll multiply this with L naught and I'll multiply this with ml. तो ऊपर वाला क्या आ जाएगा? m naught v naught L naught स्क्वायर प्लस m naught v1 L naught स्क्वायर. नहीं, मुझे v1 को निकालना है यार. So, क्या कर रहा हूँ? v1 को निकालना है मतलब I can just multiply this with m naught and add them. हो जाएगा बस. Not v1 L naught, not L naught से. You will get m naught v naught L naught L plus m naught v1 L naught L is equal to mv L square. And on the other side we get m naught v naught L naught L minus m naught v1 L naught L is equal to m naught v L naught square. इन दोनों को ऐड कर दो. सिंपल सी बात है, कोई टेंशन नहीं. We will get m naught v naught L naught L 2 m naught v naught L naught L is equal to ml square plus m naught L naught square into v. This is the answer, guys. Simple. v value कितना है? 2 m naught L naught L upon ml square plus m naught L naught square into v is the into v naught. Now what is the maximum height? So velocities ratios, height is proportional to v square na, v square by 2g. So h final will be equal to, is proportional to this square into v naught. बस simple सी बात. चलो, or I'll just write it off. v naught is equal to root 2g h लिख दो. और height will be equal to v square by 2g, which is equal to 4 m naught square L naught square L square by m ml square plus m naught L naught square whole square into 2gh by 2g. Thank you. Yes, there you go, guys. ये 2g cancel, तो height कितना हो गया? 4 m naught L naught L whole square upon ml square plus m naught L naught square whole square. There you go, guys. LLM not, हाँ. There you go, guys. This is a wonderful solution. थोड़ा लंबा है, but then I hope you understood how to solve these equations. Now for the last question of the day, guys. Today is the last question of the. This is the last question of the day. Astronauts in a spaceship are moving with. Astronauts in a spaceship are moving with constant velocity v naught. They observe a massive planet at a great distance, also moving with velocity v naught. Massive planet है, ठीक है. So what are the few things we can understand? There's a massive planet which is close by. All right. Which is moving at 120 degrees angle, उससे हमें कुछ फर्क नहीं पड़ेगा. Astronauts have to reverse the direction of the motion of the spaceship. Determine how much maximum speed in reverse direction the spaceship can acquire without expenditure of fuel with the help of gravitational field of the planet. Now one thing I want you guys to understand: anything which is central force, anything which is equal and opposite forces, everywhere you can imagine this to be like a collision. Imagine this like a collision. So this way it is best. The best way to understand it is imagine it like a nil collision. And since it is uh, it's a special case of gravitation, the collision can also be taken to be elastic collision. Got it? The collision is elastic collision. So now you can solve accordingly. एक planet एक छोटा सा mass ऐसे जा रहा है velocity v से. What is the velocity of the spaceship with respect to the planet? Velocity of spaceship minus velocity of planet. Velocity of spaceship ऐसे ले लो कुछ v naught, and velocity of planet is like this because it is given that it's making 120 degrees with the motion of the velocity of the spaceship. तो दोनों को add करोगे, so you have to subtract both of them, which means this is the velocity of planet vector. This angle will be 60 degrees. Hence the resulting velocity of this will be equal to 2 v naught cos theta by 2. Remember 2 v naught cos theta by 2, which is equal to 2 v naught into cos 30 degrees, which is equal to root 3 v naught. This is the v relative at an angle 30 degrees like this. Okay, this is the v relative of the body. So matlab initially this is how the v relative will be, but after elastic collision, the relative velocity will be opposite of this because speed of approach is opposite direction of speed of separation. V relative afterwards will be equal to exactly this in the opposite direction. मतलब root 3 V naught in this direction. Okay, got it. So initially it was along this direction. अब हो गया in the exact opposite direction. Okay. So this is the direction in the opposite direction. So now what is the maximum velocity the ship can acquire in the opposite direction is the given question. अब इसको थोड़ा simplify करेंगे. Just give me a minute, guys. तो इसका initial velocity है ऐसे v naught, and what is the final velocity of this thing with respect to the planet it acquires? It acquires root 3 v naught at an angle. ये 30 degrees में था तो ये 30 degrees रहेगा. So the components along this direction will be root 3 v naught into cos 30. The upward component will be root 3 v naught into sin 30. ये हो गया ultimately. This will be root 3 v naught cos 30 is nothing but root 3 into 3 by 2. 3 by 2 v naught, and upward direction is half of this. So root 3 by 2 v naught followed by v naught in this forward direction. तो तीनों मिलाने से what do we get? We get v naught by 2 in the backward direction and root 3 v naught by 2 in the upward direction, as a result of which the final velocity will still be equal to v naught, and the maximum speed with which it's going behind is actually equal to naught by. So there you go, guys. Awesome solutions right in front of you. So I hope you liked it. If you like it, definitely don't forget to like this channel and share it. That's all for today, guys. Don't forget to hit the like button, subscribe button. Telegram channel में Unacademy को subscribe कर लो, NSS1 कोड यूज करो, बेल आइकन दबाओ, YouTube comment section में बहुत active participation कर लो. Yeah, and install the app right away. That's all for today, guys. Adios, amigos. Until next time. See you. Tata. Bye bye.